Okay, we're in chapter 22. This is Quiz C, question number 3. Let's take a look at the prompt. Researchers conduct a study to test a potential side effect of a new allergy medication. A random sample of 160 subjects with allergies was selected for the study. The new improved brand I medication was randomly assigned to 80 subjects, and the current brand C medication was randomly assigned to the other 80 subjects. 14 of the 80 patients with brand I reported drowsiness, and 22 of the 80 patients with brand C reported drowsiness. So in question 3, they ask us, would you make the same conclusion as question 2 if you conducted a hypotheses test? And just a reminder of what our conclusion was in question 2. Our conclusion was there is not sufficient evidence because 0 is contained in the interval. There may be no difference in the proportion of drowsiness reported between brand I and brand C medication. So let's see if we get the same answer. Let's take a look at our hypotheses test when we're comparing two proportions. So here's the notes you'll need for this section. So let's take a look at the hypotheses. The hypotheses would be that the proportion of brand C minus the proportion of brand I equals 0. That means there's no difference between them. And the alternative hypotheses here would be that the proportion of people reporting drowsiness for brand C would be greater than the proportion of people reporting drowsiness for brand I. Okay, and that's because brand I is the improved model, right? We could add brand I to both sides, the proportion of brand I, and that would make more sense to us. Okay, so first we need to calculate our p-hat pooled value, which is the successes for P1 plus the successes for P2 divided by the sample size in P1 and the sample size of the second brand as well. So here we go. We just plug it in, plug it in. We know we have 14 successes and 22, so our numerator is going to be 14 plus 22. And we have a sample space of 80 and another sample space of 80, so our denominator should be 160. And here we get our P pooled value. What just happened? Crappy fish. Sorry about that. I have to undo what I just did. I know there's a button there. I'm sorry. Let's see what happened. Oh, I think that was in front of the hypotheses. I love life. So hopefully this is our P pooled value. Either that or I deleted it. I'm trying to get better. Okay. Nope. That was P pooled. What happened to it? Oh. Let's see if I can find it. Oh, I erased it. Come on. That can't be true. Let's see what's under here. Nope, that's our Z. Crap. All right, well, let's say I plugged it in, okay? And I know I had it there. What happened to it? Let's see if I can hit my undo a couple times. Let's see if it's there. Yes. I'm sorry, very excited. Okay, here's P pooled. As I said, it was 22 plus 14 in the numerator, which is 36, 80 plus 80 in the denominator, which is 160, which gives us a p-hat pooled value of 0.225. Okay, we're going to use that value to calculate the standard error. It's called the standard error pooled for the difference in the sample proportions. Okay, so again, you can see we're using our p-hat pooled value. Okay, so we're going to use this 0.225. So we should have 0.225 times 0.775 divided by 80. And it's actually going to be the same for both here because the sample size is 80 in each. So I guess the key is if you have a picture in a picture, you have to be careful what you delete, right? So here's our standard error pooled. and our value is 0.0660. We know, according right here, it says when the conditions are met and the null hypothesis is true, this statistic follows the standard normal model, so we can use that model to obtain a p-value. So we know our normal model is in the form 0. And why 0? Because remember, we're trying to reject the null. So the normal curve for the null hypothesis is it's equal to 0, no difference between brand C and brand I. The proportion of drowsiness reported between brand C and brand I. And we know we now have a standard error of 0.066. Okay, so here we have our normal model. We've calculated our standard error. I'm going to calculate the z-score because it makes so much more sense to me using my calculator with the z-score in this particular case. So calculating our z-score, and here you go. Oh, gotta switch my pen. There we go. Okay. And here's our z-score. Our PC, our p-hat for brand C minus our p-hat for brand I was 0.10. We did calculate that in question number 1, and that is called the observed difference in the sample proportions. So the observed difference in our sample proportion is 0.10. Subtract 0, this is the p-naught. That's our hypothesis value, that there's no change. The difference is 0, divided by our standard error. That gives us a z-score of 1.5. Okay, so if we come over here to our nice little curve, let's label our curve. Our data values, our null hypothesis is 0. Our standard deviation is 0.066. And actually, we're going to be comparing that to our 0.1. Where would that be? Well, now I have a better idea. 0.1 is actually has a z-score of 1.5. So if my mu is 0 and I have a standard deviation of 1, 1.5 would be just a little bit, 1.51 would be a little bit more than 1.5. So now I have a great idea where on the curve this 0.1 would lie. Right, there it is, 0.1. Okay, and again, that 0.1 represents the p-hat of brand C subtract the p-hat of brand I, and we're comparing that to there being no difference, that the difference being 0. Okay. And when we plug this in our calculator, I would again use the mean of 0, standard deviation of 1, and using my calculator and normal CDF, just a quick review. Normal CDF is lower bound, upper bound, mu, theta. So if I use my z-score, my lower bound would be 1.515. My upper bound would be some very large number. I always use 999. My mu would be 0 and my theta would be 1. Okay, I just think that's a little bit less confusing. Using this 0 tends to make me a little wacky. I know nothing, it doesn't matter. I'm a little wacky anyways. But if I plug that into my calculator, I would get a value of 0.64. And just a reminder what that value is, that's my p-value. Okay, so here, my p-value is equal to 0.064. Now notice there was no significance level given in this problem. So if there's no significance level given, we look at our alpha level equal to 5%. So because our p-value is actually 6.4% roughly, we would say, oh, we have a high or a large p-value. Therefore, we fail to reject the null, and we could say there is no evidence to support the suggestion that brand I reduces drowsiness more than brand C. Or you could say we failed to reject the null hypotheses. Therefore, there is evidence to suggest that there is no difference in the drowsiness between brand I and brand C. I hope this helped. I think I'm getting a little better. Typing these out seems to be okay. It seems to be making my life a little easier. And good luck. See you tomorrow.